Okay, so for this video, we're going to look at a new concept for you, which is called a tangent. Now, don't worry about that for the moment. We'll get into it shortly. But firstly, I want to talk about the second part of the title here, which is what we call an angle of elevation. Okay, so that's where we're going to start. An angle of elevation. Elevation means to go up. You have an elevator, it goes up. So an angle of elevation is the angle that something goes up by. Okay, so this angle down here is our angle of elevation. So this is an angle of elevation. Because if something has elevated from down here to up here, this is the angle that it has covered to get there. For the purpose of this video, I'm going to use theta as the angle of elevation. We've seen theta before. It's the Greek letter theta, or maybe we haven't seen it, but fine, it's a Greek letter theta, and we just use that as a reference angle. Okay, now for an angle of elevation, again, you can see in this picture, the same as what we had in the last one, we have a rise over a run. Okay, now for any given angle of elevation, so for a given angle of elevation, the ratio between the rise and run will stay the same. Okay, so if we have a set angle of elevation, the ratio will be the same. So for example, if we have an angle here of, I don't know, 35 degrees, any angle of 35 degrees will give the same ratio between the rise and the run. Okay, so the relationship between the rise and the run will always be the same for that angle of elevation. That's probably still a bit confusing to you at this moment, so obviously I'm going to explain it to you. We're going to do it with an example. But that ratio we call the tangent. Okay, so that's what we have here with the tangent at the top. The tangent is related to the ratio between those two sides. Okay, it actually has a much bigger meaning further on that you'll learn about later, but for now, the tangent is the ratio between the rise and the run for a given angle. Okay, we might write something about a little bit about that in a moment. So, yeah, let's do it. So the tangent of an angle is the ratio between the rise and the run for that angle. Okay. Now, obviously, we're going to look at how to calculate this. So let's start with a triangle. Okay, so we have a triangle here, almost. And in this particular triangle, I'm going to say that the angle of elevation is 40 degrees. Okay, so that angle there is 40 degrees. And let's say that the rise is what we want to calculate, and the run is 10 meters. Okay, now the ratio between the x and the 10 will always be the same for that angle of 40 degrees. So what we can do here is we can write the tan, or the tangent, we write it in short form as tan, of theta is equal to the rise over the run. This is our standard formula for tan, for tangent. So the tan of theta is equal to the rise over the run. Now in this case, theta, the angle of elevation, is 40 degrees. So we're going to write the tan of 40 degrees is equal to the rise, and in this case our rise is x. We'll put rise on there just so that you remember. Rise and run. The rise is x, so we'll write x in place of the rise, and the run is 10. Okay. Now, this sort of equation you should be able to solve quite easily because this is what we did earlier in the chapter. So again, you've got a denominator down here. We want to get rid of it. So we're going to multiply both sides by that denominator. So we're going to do 10 times on both sides. Now, again, we want x on the left at the end. So we're going to flip the equation around when we do the next step. I'm going to write x is therefore equal to what we have written here, which is 10 times the tan of 40. Okay, now what on earth is this tan? How are we going to do this? Well, actually we have a nice set of buttons on the calculator to help us with that. So what you can see here, here's my calculator, and you see in here above the yellow buttons, you see here sine, cosine, and tan. We're going to talk about all three of them in more detail later. But for now, you have here sine, cosine, and tan. So we're going to use this tan button. So x is equal to 10 times the tan of 40. And you should close the bracket as well. It's not 100% necessary, but it's a good habit to get into. So 10 times the tan of 40 will give us our rise. And that is 8.39. So x is approximately equal to 8.39. And we need to think of our units. In this case, it was meters, so 8.39 meters. So you have just calculated the rise. All right, we'll do another one just to make sure you get it. This time we're going to calculate the run. So let's say we have another triangle. I'm going to draw the triangle backwards this time because you do need to get used to shapes in different orientations. So this is our triangle. Our angle of elevation is going to be 13 degrees. Our rise is going to be 4 meters, and we want to calculate the run. So we have a rise over the run. If you need to label it, label it. It's a good idea. Okay, always start with the formula. So the tan of theta is equal to the rise over the run. All right, in this case, theta, our angle is 13 degrees. So we're going to put that in, the tan, whoops, my pen's not working. There we go. The tan of 13 is equal to the rise, which is here 4, over the run, which is x. Okay, again, to get rid of the denominator, which is really annoying down here, it's making a mess of my equation, I'm going to multiply both sides by the denominator, so both sides times x. These x's are now cancelling out on the right, so we have x times the tan of 13 is equal to 4. Okay, we want x by itself. So we want to get rid of all of this. Now, this is multiplied by x. The opposite of multiply is to divide. So we're going to divide both sides by tan 13. Okay, and then we end up with x is equal to 4 over tan 13. Okay, if we plug that in our calculator, 4, and in this one I have a fraction button. If you have a calculator like this, you can use the fraction button and put tan 13 in like this. Okay, if you don't have this calculator, you don't have that fraction button, you can just do 4 divided by, but make sure you put it in brackets, tan 13. Without the brackets, it's also fine. But again, you want to be in the habit, if you're going to use the divide symbol, of putting the denominator in brackets. Okay, and then we get 17.33. So x is approximately equal to 17.33, and the units are, again, meters. Okay, So this should be all you need in order to calculate these tans. And we will go into the next step in the next video. So enjoy.